In this session, we are going to look at a Titanic case study. So the Titanic case study is actually a challenge from Kaggle, which we will look at into a bit more details. So basically, we really want to learn from disaster. We've got access to the data set, and it should give us all the details that we need or some basic data that we can work with. So as a start, I'll let you pause the video and go to this particular video, which introduces you to the Kaggle challenge and how it works. The whole idea is to basically try to analyze the number of survivors and also the number of non-survivors using the various predictive algorithms or predictive techniques. So it's basically a classification problem. So if you go to Kaggle and you search for Titanic challenge, you see Titanic machine learning from disaster. Select that one and it should give you access to all the details. Again, you get access to the same video that the link was provided on the slides for you earlier, and you can read more about the challenge here. From here, you can see the code in terms of what other people have done relating to the data set, and also you get access to the training, and then the test data set is split for you. You can see what various people attempted that various people have done. You notice this is a really active data set or active challenge. So you've got someone who's contributed to it like within 4 hours ago, and you see various discussions around. You can explore more from what efforts that people have made. And of course, once you finish your implementation, you can upload your yours as well. So I'll let you finish watching the video, and whenever you finish watching, you can continue or come back here. So the challenge is to build a predictive model that answers questions, which is what sort of people were more likely to survive the Titanic sinking. So you want to consider what factors may have led to someone surviving or not surviving. And from Kaggle, you can start by evaluating things like the actual data. So if we go back to Kaggle, you get access to the data. And from there, you notice that the data is actually well detailed. So it's you've got very good features like the survival rates, the class of the people, the sex and the age, and number of siblings, where they dispatched from, the ports that they dispatched from, the tickets that they have. So you've got various details that you can actually, it's quite a well documented data that you can make use of. And you can things like the comments other people have put, and also have a look at people's code and also comments on people's code. So yeah, there's a lot to learn from Kaggle if you really want to dig into it. Obviously, you get access to Introduction to Machine Learning resource here for you that you can play with. And also, I would strongly recommend that you have a look at it, and you get general introduction to Python course as well that you can learn from. So our aim is to build a classifier that divides our journey. We will divide our journey into 5 key steps, which is 5 key pipelines. In terms of this would be a template that you can use for your other implementations as well. So let's jump straight into it. I suggest you go to Google Colab. So that will be colab.research.google.com. And from Colab, you see your previous implementations. You can create a new notebook. I'll wait for mine to upload. And as it uploads, let's look at what these 5 steps are. So our general template that we'll be sticking to is the title, problem statement, and the first step being importing the libraries. Then we will import the data sets, and also we will explore or visualize the data and prepare the data for training. Then we can actually model the training. And of course, these are actually 6 steps. And last one can be the model evaluation. So if we go into the first step, which will be our title, I'm just going to switch it as a test, and the title will be a simple logistic regression model. So I'll just toggle that and shift enter, and then the problem statement, I'm just going to copy my problem statement from Kaggle. So I'll just next one being problem statement. And that should be a test. So with me as I delete that, get rid of that. So we have our problem statement, then we can show where we are getting the data from. Our data source in this particular case is going to be from Kaggle. So the Titanic case study. Toggle that, make it clear. And we will import our libraries next. That's our first step. And the next step will be to import the data set. Then we'll prepare it for cleaning, of course. Shift enter, or you just press play. And after we prepare the data for cleaning, we want to go ahead and add a bit more to it. Where we would, next step, bear with me as I sort out the mouse. Yeah, so resuming our recording, yes, we did skip a step, which was helping ahead of time. So our next step will be to, as our step 2, will be to explore the data set. So explore and visualize, or visualize the data. And after we explore, visualize our data set, we'll prepare the data, and the next step after that will be to train our model. So after we train our model, we can add an additional step, which is to evaluate the model. Maybe that's the code. So we just make a test. Then I can delete that. So now we have our steps. We're going to start off with some content there. Let me just delete this. Basically, some title, problem statement, where we're getting the data from. In our case, the data is coming from Kaggle because it's the Titanic challenge that we are doing. So I can go to the overview, Titanic challenge. And from there, I can actually copy the challenge and paste it across. So I'm just going to copy the challenge and I'll paste it across into the data, the problem statement. Of course, you can clean it and make it a lot easier to visualize. So at least you want a really well-documented interface to help everyone who is looking at your data. It's quite professional to stick to it that way. So you really want to try to go ahead with that. So the next step is to import our libraries. So these are the libraries we've been using, which you use as a template. So you've got import pandas as PD, then you use NumPy, Matplotlib, Seaborn, and OS. It just becomes like a common template that you end up using for almost every implementation you have. So let's add our first line of code that imports the library. So Shift Enter, we have our libraries imported for us. Then we'll go into importing our data set. So I've uploaded my data set into my Google Drive. If you are using Jupyter or another alternative, of course, it's going to come from your local drive. So because we are using Google Colab, I'm going to link it to my Google Drive. In order to do that, I need to go into Colab and then find mount my drive. So let me put it in the right session. So import data set, add my code. I'll go into Colab and then mount my drive. So yes, the drive is mounted and we've imported the library for drive, and let's make use of the method. So from drive, we can make use of the method mount to mount the drive. And it asks me to link it to my Google account or Gmail account. So I enable that and I'll just pull it on the side. Complete. Enable, allow. And after it's able to link up, it should show me that it was able to mount successfully. Still processing. So yes, we've managed to mount our drive successfully. And I believe I stored it into AI3. I'll find the right file and bring it back up. So basically, next one. Yep, we have imported the drive from Google Drive, and then we've mounted it, and we want to link it to the right path. Yep. So to link it, I believe I'm going to go into my Google Drive to find exactly which file I use. So you'll do the same. So you go into your Google Drive, search for Google Drive. Go into your Google Drive, as I do the same on my side, and I will find my drive folder. And I have uploaded mine into AI3. So I call my file AI3. So let's find it. And then link our data set. So I'm going to go into it to find out whether AI3 actually exists. So I'll use this OS command and it will start with a command prompt and I will find the path. Say AI3 as it actually exists and what's in there. So Shift Enter. So it can't find AI3. So let me see. Let me go to the next one. mount it. Good. Then try to see whether, okay, so yes. Again, I need to go into my drive, which is where my Google Drive is. So my drive, then AI3. Good. So I see in the AI3 folder, I've got a file called Titanic, which is the data set I'm using. So let's read this file. So to read the data set, I'm going to make use of pandas, which is the PD. So pandas, we have pandas as PD, and we are going to assign the data to training set. And from the data training set, we'll assign it to, we'll use panda, so PD, let's read. This is a CSV file. We have various alternatives that we can use. But in this, but we can use read PDF file and other files. So in this case, it's the CSV file. So we read it in there. So shift, enter. Oh, give it name, Titanic.csv. And shift, enter. So yes, we've read the file and we have various options to read the content of this file. And in order to actually visualize that, we can just have a quick look at the data where we can say training set head, or we can look at the first 10 elements of the training set. The same, we can look at the last set of elements in the training set. So we can just look at last set of content, looking at the tail, or looking at the last 20. So we've got a wide range of options that we can use in terms of just having a quick peek at the data content, and I'm simply going to paste all of them here for you to have a quick look at. So in terms of step, yes, we've mounted our data set, and then we have a look at the actual contents in terms of how we can just look at the head or the first few lines or the last set of lines. And now we want to move to the next step, which is to visualize the data itself. So basically, we just explore the data at this stage, and we want to explore it a bit further to see its content. So let's go to explore the data. And usually it's really good to spend more time to understand the data. So once you really understand how the data looks like, it becomes a lot easier to go to the next step, which is the step number 3, which is cleaning the data, and of course, performing your training. So, or preparing your data for training. So let's explore the data. So the first thing we would want to do is to count the number of survivors. So you notice from the data set, we've got those who survived, we've got a passenger ID and number of survivors on there. So we want to make use of some Python codes to find the number of survivors. So we can actually say that for survived, then we go into our training data set, and we are going to pull from the training data set the number of survived, and we have a 1 for whether a passenger survived and a 0 for whether a passenger did not survive in there. So let's pull that out, which is basically whether we're creating a variable called survived, and then we just putting out whether going to the training set, and then we find whether a passenger survived. And in this particular case, if it is equal to 1, then it means that the passenger survived. And luckily, Python allows us to do this. So we just execute that, And in order to see, we can either print it out or we can simply type survived. Shift enter. So we see that we've managed to pull out every single passenger who survived. And in this case, we have only one for those who survived. And the other ways that we can use to visualize the data or analyze the data as we have received it, which is basically we can print out or we can find out the total number of data in our training set. So Python allows us to use length, so we can use the length and print out the length of the total number of passengers. And in this case, we have the data set, the total number of being 891. We can visualize other things such as just the number of passengers who survived. So we can look at survived, shift enter, and we see that only 342 of them survived. We can look at things like looking at the number of non-survivors. So let's look at the number of non-survivors, and we can say no survive, and we assign no survive, quite similar to what we did to the survivors, but in this particular case, we just simply assigning it to 0 because from the data set, those who did not survive, you just assigned to 0 for no survivor in the survivor column. So execute that, and we can look at the content as well. So we pick. So straight away, we see that it's printed out the non-survivors for us, and we can easily analyze the data a bit further. So again, we can look at the total number of passengers and the total number of passengers who did not survive and compare against each other. So we just print the length of the training set and that of the non-survivors. And of course, you can do a bit more, which is basically just put no survivors against total number of passengers and also against the number of survivors as well. So out of the 891, we see that 549 did not survive. And there's more we can do, such as from the total numbers. So let's have another alternative. So from the total number of survivors, total number of passengers, we can look at the percentage of non-survivors and also the percentage of survivors as well. So let's start off with the percentage of survivors, with percentage of passengers who survived. And we visualize that against the percentage of passengers who did not survive. So again, shift enter, and we see that out of the 891, about 38 did not survive, and about 38 survived, 38%, I would say, and about 62% of them did not survive, unfortunately. So to make it brief, we've been through looking at the data into different ways we've printed out, and basically it would be good for you to try this out. So pause the data at some point, and I want you to try the non-survivors yourself before looking at how I did it, and then we can continue the video whenever you are ready. Of course, you may have to go back and forth at some point. So once you are done with that, I would also want you to try to print all of them cleanly against each other, which is total number of survivors, total number of non-survivors, total number of passengers altogether, and also you want to print out the percentage of non-survivors and percentage of survivors in one go. So just pause, complete that now, and as soon as you're ready, you come back and you continue with me. So I have mine, and I'll paste mine here. So it's just the same set of lines that we have explored, and I will just execute again. So it's a lot cleaner all against each other to visualize. Good. So we want to use more visualization techniques to view the content or to visualize the data. And earlier on, we imported Matplot. So we have Matplot imported for us, and Matplot will give us the imported data as plot. It will give us access to some basic plotting functions. So let's make use of some of the plotting functions that we get from Matplot. So first thing would be to use a bar chart. And from the bar chart, we want to see the chances of survival. We're just visualizing the data at the moment. So from the bar chart, we want to indicate the number of people who survive based on their class, just based on their class alone. At the moment, we see like we can actually say that from plot, we want to create a figure, and the size of the figure that we are using, of course, we have the length and then the height, which is 6 inches and then 21. You can adjust it to see how best you can visualize yours. And we want to create 2 different plots, okay? So 2 different plots, and we say we're using subplot. So the first subplot where we have the row that we're using, and then of course we've got the column, and we are saying that this is the first figure, right? So you can play with swapping this around to see how it actually appears for you, right? So in terms of number of columns, we are actually expecting 2 rows. So first one and then the second one. So this is the second one, and it's going to be a first figure as well. So from there, we just say, basically, we make use of SNS. We have SNS here, which is from Seaborn. And from Seaborn, we want to count plot. And we pick the P class, which is the class from the data set. That's all we're doing, right? We're just picking the class from the data set and then plotting that. So we want to get our second plot or our second figure. So we've got our 2 rows and 1 column. So the figure is in 2 rows and 1 column. We've got figure 1, we're just plotting figure 2 right now. So to have our figure 2, we're just going to pull. Let me get rid of this. And then we go in there, it's the same, the class. And then what he'll allow us to do is just to compare both or plot more than 1 bar in there, so we can easily compare the number of survivors and then the non-survivors, right? So we plot in the class, the total, and based on the category. I think we can see from the class data when we have, we see from the class, we've got 3 different classes. We've got class 1, class 2, and then class 3. So we're going to have a look at the class distribution, and then in the next row, we want to print and compare those who survive with the non-survivors, right? So I'll press Shift Enter, and hopefully it won't scream at us, and we notice that it's plotted nicely for us, where we have the class against the number of counts, and in there we say for each class, we notice that we have quite a large number going into a higher class, or maybe first class, right? So we look at the data itself against so this was the first figure that we have there, the first figure, and then we look at the second figure and see what is happening. So blue, it means that they didn't survive, and then 1 is, of course, you've got the number of people who survived as well. So we notice that for the lower class, those in much lower class, the number of non-survivors really high. So the number of survivors are really high for first class, sorry. So if you look at first class, you've got number of survivors being much higher than the number of non-survivors. So probably if you are in first class, you likely have stand a chance of surviving. While second class, then the number number of non-survivors start dropping. And then third class, the number of survivors actually drops significantly, right? So number of non-survivors, the lower your class, the higher your chance of not surviving. So let's make a note or remark in this particular side of the data so we can actually have that there. I'll save my work now, press Control S to save the work. And again, we can look at, I wanted you to try something, so I want you to pause the work now, so pause the video, and I want you to calculate and visualize how many survived based on their sex, how many survived based on age, how many survived based on sibling status. So pause the recording now and then try that. Whenever you are ready, you can continue and work alongside with me. Okay, so hopefully you had a chance to work on it and you have completed based on the task that was given you. You may work alongside with me, but I prefer that you have completed your side first. So we want to look at the number of people who survive based on their sibling status. And in the first instance, again, we're going to have similar content as this. We can actually just copy the same thing and paste it at the bottom where we just simply change this to SB. I think that is what we've got as the heading for the number of siblings or the label for it. So this will be SB, this will be SB, and it should be able to work really well with a template for us, as a template for us. So I input that, and I have, so same line of code, just simply change that to SB and then SB. So Shift Enter. Then you noticed again the number of survival, those who survived being 0, and then of course number of non-survivors being 1 as well. So you notice that you've got the less number of siblings that you have, the lower your chances of survival. So basically those who have 0, but still the number of counts were extremely high as well. So in general, just plotting that. So there are several ways that you can play with the data to visualize things as well. And we want to see again the port they embark from. I'll leave the actual data analysis to you to come back to me on it as well, which would be quite exciting as well. So I'm just going to just a bit of line of code as well on there for you across. So we want to see from the number of survivors based on the port they embark from. Let's use a code in the first instance. So let's do some coding on here in terms of those who left from Southampton would be S, and then in Queenstown would be Q, and then of course you look and also C. Then again, similar code, but we just use embark. So let's come back to the data. We've got a port they are leaving from there. So again, Shift Enter, and give us clear distribution. And we notice that for those who survived, it's quite interesting that it looks like we had a lot of passengers coming from Southampton, quite a lot of passengers, and also in terms of number of counts. But again, the survival rate seems to be dropping as well. And if you compare that, I think a better way of represented this is actually the percentage difference. If you compare that to those who left from Queensland, Queenstown, notice it's quite low in terms of if you come from Queenstown, maybe you had a higher chance of survival. So there's more analysis that can be done. And of course, you can view it according to age distribution, which I will just give you a bit of code and I'll let you do the analysis on your side as well. So just basically to visualize it based on the age. So based on age, we just use plot. Then we have a figure size. So the figure size that we have, of course, we've extended it because you see that the data distribution is quite different. And we have using age. So let's see what happens with age. And also you see that from the age, we have no kids who all the kids survived, and we have non-survivors. So if you're a baby, maybe you have a higher chance of surviving. So basically just on there, say if you're a baby or your baby had a higher chance of surviving than adults. It would be interesting to see why so, though. It would be quite interesting to see why so. So yeah, I will allow you to play with it. Things like swapping the 2 and the 1 on here. So making this 1, making that 2, and then also swapping the figures to see figure position to see what happens in terms of with the data. Then our next task is to prepare the data for training. So to prepare the data for training, you want to clean your data. So to clean the data, let's visualize from the data set what is the missing data. So we want to explore from the data set if something is missing. So that's our next step. So let's find out which data is missing. So we go into we use heat map. Let's use SNS heat map. And from the heat map, we would make use of our training data, of course, and then we'll say wherever is empty, we want to paint it blue, for example. So let's see. Straight away, you notice that there are quite a lot of missing data from the, there's some missing data from the age, and then also missing data from the cabin as well. So let's have a look at the data. Yep, we see cabin, we see none missing as well. And then the age, you see none on there. So we have some missing data. And our goal will just be to get rid of this missing data in the first instance, right? So let's drop the data that we cannot find or the missing data in there. So let's drop them. To me, it's just to delete them from this instance. Of course, you can find a dummy and then store it in a dummy, or basically you can just find each missing data and then delete it. Well, I'll explain what I mean by dummy in this particular case. So basically you can have another, maybe say dummy training. You can assign this to, if you set this in place to true, what it means is that we will actually delete it from our original data set. So you may want to duplicate the data by assigning the data first, or basically you can just play with assigning it to true or false. But in this particular case, I just want to clean it. So I will just place it side by side for you to try with. But by all means, make sure you have a copy of your data before you do this. So if we set it to true, it means that we're actually deleting the raw data. If we set it to false, then of course you are retaining it and just using a virtual deletion, so the data will still be preserved. So I just press Shift Enter in this particular case. And you notice that in the first instance, it's deleted them for me. If I try to run it again, it's going to tell me that it can actually find it, because of course it's gotten rid of all the empty contents for me, which is good. So we want to drop, let's drop a bit more. Let's drop the port they and back from, the empty ones from the port and back from. So we're just going to do the same for port. So we go into the training set and we drop in things, more things like name, ticket, the port and back from, and other things. So just make life easy for ourselves to make the data a lot cleaner. So now let's visualize our training set. So we say training set. Shift Enter. So you see we've got a lot cleaner data, much more simpler than what we started off with, which was quite a lot of things on there. So we get to see just a bit more cleaner data. But again, let's try to find out whether we managed to drop everything. There's still a bit more work to do, I believe. Shift Enter. You notice that there is still some missing values on that in the age. So again, we can try to see the average age, for example. So we have a figure using the plot. And from there, we can look at things like, we can use a box plot to find the average distribution of the age. So we take the sex and the age, and then you see a box plot. So you notice that the average age distribution for the male is between 20, 30, and the same for female as well. So you get to see where the average lies. So a bit more, we can use a bit of heat map. So we just do some finer cleaning. Let's see how our data looks like, whether we still have some missing values. Shift enter. So this few missing values in there, but we're still okay with that anyway. Yeah, so here we want to make use of, some really nice templates that is used for cleaning that I found and I really like as well. So we can, of course, adjust it to depending on your data and how your data looks like. So basically, we just want to say fill the age, and of course, we extract the age and also extract the sex. And we say if it is null, we want to replace it with some content, so we get rid of some things, and we can actually return the age. So just a bit of some cleaning for us as well. So I just press Shift Enter at this point, and I will, of course, return the age again. So to the data and the sex, and I'll apply the fill age on there. So let's have a quick look. And we go into our training data set, and again, we apply the fill, and then we just print it up. Yep, so just that's the return. So just following this algorithm, we've got it to return on there. And let's try this. So now you're seeing that our data set is a lot cleaner. We've gotten rid of all the missing data, and we have also converted the 9 to 1s or 0s. So it's a lot easier to visualize our data, and then also working with the cleaner data. So let's see how we can replace the non-test with also test as well. So let's say walk through this a bit. So I'm going to create a dummy, and so we're going to get dummies, and we get a training set, and we want to assign it to the female as well. So Shift Enter. And we can see we can have the male against our females, and then the number of entries, of course, being 891, and it's quite clean. We have 01 representing the data, unlike the original data source that we started with, where we have sex, we have female, male, female, and through our algorithm, by following this, we've managed to replace just assign 1 and 0 to 1 being male, and then also in there, and then 0 being non-male. So we got the data in a lot cleaner way. It's a lot easier to do this. So at least you get to have data in number format in order to work with, rather than data being represented as test values. So we will get the males and assign it to males. So at least we extract the data from there. So we go into the training set, and of course we want to drop the males, but we just want to find a temporal space to keep them as well for now. And afterwards, I'll call male. You notice that we've extracted the male only to keep it. It's quite important you do this step. Make sure you don't skip this step, as you may have some issues if you skip it, because you'll most likely be deleting the data completely, and you don't want that to happen at this particular stage. So afterwards, we want to let's drop the column sex. Somebody will ask, why are you doing this? Yes, it's good to have good and nice and clean data. So when people actually see your data as well, or when you work with your data, it's a lot easier. So we're going to go into our training data set, then we drop each sex, and also we setting it to true. We say a copy of it into male anyway. Shift enter, and that's the sex drop for us. If we try to run it again, we notice that give us an error because it can't find it. It's gotten rid of it for us, which is good news. So now we can visualize our training set. Let's visualize the training set again. Shift enter. I'm going to pause this recording for us, so at least it doesn't store it. So just bear with me as I pause this, and then I continue with the recording on the other side. That records it gives us our training set, and we see a simplified training set. The sex has disappeared, so we've dropped it completely. So drop more that we don't need. So let's go back and add the male column, which is the male column we deleted. So if you're only interested in males, so let's add the male column again. So I'll do shift enter, and it should resolve it for us. And you can again visualize the training set. And you see that it's added the male for us. So we have the male column added back on it for us. It's good so far. So a bit more to add. So let's drop some more. Let's drop the target column. We do so we do the train and test split. Let's do the train. So we've added some more things. You can play with it a bit more, but make sure you save it first using a line like this one before, so you can actually go back to add some things. So let's get into our training as well. Before we do our training, maybe we can drop some more things. Shall we drop the column that we before we do some training? So let's drop some target columns. So we're going to say, let's drop the survived values and other things. So it's easier because that's the target. So you're going to say, as training, let's drop the survived. And we can split it into Y as well. And the Y will be the training set. So we've got our training set that we drop in, and then we've got the XY split in there. Good. So this like separating the XY data that as we did for linear regression. And we want to look at, of course, doing the split with C1 in here, scikit-learn. So we're going to scikit-learn, and we want to import the train test split. So train test split here. Just press shift enter. Give us access to the train test split. And from the train test split, we want to again we want to split our X and Y data separately. So similar to what we've done before, we're going to have the X training set, the X test set, the same for Y training and test. And the only thing we're doing differently here is that, of course, we are assigning the 80 training data, and we're using 20% test data. And each time you run this, this train test split will try to randomize the data. So we want to randomize the content. So we want to fix it by just using the fix 10. So it should be sort of replicable. So shift enter, and that will perform our XY split for us. Then we want to focus on fitting the actual data into our model. So we've done our split, let's fit into our model. So we just say fit our logistic regression into training. So we go into sklearn and we import logistic regression. Just as we did for linear regression, right? So from sklearn, we will go into the linear model, and then we import logistic regression. Then our classifier, we want to have a classifier which is logistic regression, and we are setting the randomized set to 0 for now. So let's fit our X and Y training data set. So we take our logistic regression and we fit the S and the Y training data set. Again, Shift Enter, and that will be set for us. So it's done our fitting for us, and we want to see whether our model actually works now. So now let's do some prediction, right? So we will say, let's do a Y predict test. So we do Y predict, and we will say, we call our classifier, and then we predict with the X test, of course, X test data. So we making use of the X test data, feeding that into our model to do our prediction, and we'll pass that to Y predict. Good. It's not screen data so far, so it means that we're still on track. Now let's visualize our Y predict. So you just say Y predict, and then run the test and Shift Enter. So we have our predicted values for us. By all means, of course, note that this random state, you can omit it, but as this actually helps those who had questions about when they ran it, they ran the model last time, and especially with linear regression, and they gave them different values, they tried again, they asked something slightly different. That's because your training set and test set are being randomized. Okay, so let's compare our predicted values to the actual data, or actual values that we have. So let's take our Y test data. And we notice that's what, yeah, quite similar. 0, 0 is doing quite well. 1, 1, 0, 1. Well, there is a mistake somewhere here. There's a slight error. And then again, it's quite similar. So most of them quite similar. So it means our model is doing quite well. I'm happy with this. People can change more if they want and other things. So far we've trained our model and we've tested our model. We've done our prediction and we've tested our model. The next thing to do is to use confusion metrics. So from scikit-learn, of course, you can explore scikit-learn more to see what options are available to you. But from scikit-learn, we can actually import the confusion metrics. So it's not screen data, that's a good thing. And we want to pass our test and predicted values to our confusion metrics. So we call it CM for confusion metrics, and then we pass our test and the Y predicted data onto that as well. So let's see whether it's screen data. It's not screen data anyway, and we want to visualize it using a heat map. So the heat map obviously is going to come from C1, isn't it? So we go into C1, and so we go into the SNS, and then we have our heat map. I believe C1 was our SNS. So we've got C1 SNS on there. Sorry for the scrolling, how fast I'm scrolling through it, but in case it gives you any. So we get C1, SNS, and we have actually tried to plot our confusion metrics, but we want to fix it, the format to decimal, so we get to visualize it. So good, we get to see our confusion metrics, and we notice that we are about 99 for the actual true positives, and we've got about 45 for true negatives. It seems like it's doing well yet, and of course there is more ways that you can play with it. So let's look at some evaluation, right? So let's visualize the accuracy, and again we go into sklearn or scikit-learn, and we can import the accuracy. And let's visualize the accuracy score. So let's find the accuracy score. So from the accuracy, we find the accuracy score. Then again, we take the test and then the predicted test, and then we have accuracy around 80%, which seems okay. It looks good so far. So if I want to visualize my recall, again, I go into sklearn and I import the recall. And we've got recall method, and we want to make use of the recall method. So from the recall method, we have the test, and again, the predicted, and we find the recall. So we get, again, recall about 0.8, 0.84, and then also 72, about 84, and then 72%. We're just doing quite well at the moment, so which is still not bad, right? Let's have a look at the precision. So SQLN give us access to tools that makes life a lot easier for us. And of course, you can use this as a template across other things as well. So you look at the precision and calculates the precision for us. You see around 85, which is also good. And last thing we talked about was the F1 score. So let's have the F1 as well. We look at the F1 score, and F1 is around 84. So all the scores are quite good at the moment, or quite high, but easier if we just plot all of them against each other. So from sklearn, you can actually, or scikit-learn, you can actually do something like report, and then the report, you can actually print all of them against each other. So sklearn, report, shift, enter, and you see the report printed out against each other for it. So that's where I'll bring this to close. So we managed to use we managed to get the confusion matrix, and we started off from simply partitioning our work, or having a good layout in terms of how we distribute our work or document our work, because it's called interactive Python notebook. It is a notebook, and you want to visualize the content clearly. So we of course did some documentation. We imported the libraries, which is common libraries we use, and then we imported the data set, and we explored the data set in various options, and we visualized the data and did some cleaning, a lot of cleaning around after visualizing the data, and eventually trained our linear regression model. And after training, and we did some tests, and we have looked at the heat confusion matrix, and also evaluated various things such as accuracy, recall, precision, and F1, and had a look at all of them against each other. So I'll pause the recording here, and if you have any questions, to remember to ask.